This is an introduction to naming ionic compounds with transition metals. The transition metals are the elements in this part of the periodic table, and when we write the name for an ionic compound that contains transition metals, those names usually have Roman numerals in the middle of them. So in this video, we'll learn how to take the formula for a compound that contains a transition metal and how to write the name for it with Roman numerals and everything. So transition metals. The transition metals are the elements in this part of the periodic table here, and I've written in some of the most common. I'm also going to be talking about some of the metals over here, which aren't technically transition metals, but they act a lot like them. These metals are unique because many of them are able to make multiple ions with different charges. So iron, Fe, for example, is able to make an Fe2+ ion, but it's also able to make an Fe3+ ion. Okay, this is different from the metals, say, over here, that tend to always make ions with the same charge. Sodium, for example, is in this +1 column here. And so when sodium is in an ionic compound, it always makes an ion with a 1+ charge. Magnesium here is in this 2+ column, so when it is in an ionic compound, it makes a 2+ ion. But the transition metals can make a wide variety of different ions with different charges. Some of them can even make 4 or 5 different ions, each with a different charge. So these different charges on transition metals really come into play when we want to name a compound that contains a transition metal. So here we have FeCl3. And for the Fe, the iron, we can't tell right away, just by looking at this, whether the Fe is Fe2+ or whether it's Fe3+, right? We have these two different types of ions that Fe can make. Now, we can distinguish between these two ions by using Roman numerals to give them different names. So the Fe2+ ion, we call that iron 2 with the Roman numeral for 2 in parentheses. The Fe3+ ion, we call that iron 3 with the Roman numeral for 3 in parentheses. And we'll use these ion names when we want to name the whole compound. So if the Fe here turns out to be Fe2+, we'll call this compound iron 2 chloride. And if this iron is iron 3+, we will call the compound iron 3 chloride. So in order to figure out whether we're talking about iron 2 chloride or iron 3 chloride here, we got to do a little bit of math and work backwards to figure out which of these two charges iron has in this particular compound. Let me show you how to do it. So to find the charge of a transition metal, we start by focusing on the ion with a charge that we do know, that's certain, that's not going to change. And for this, that's going to be Cl. Cl is in this column here on the periodic table, so that we know that in an ionic compound, Cl always makes an ion with a 1- charge. Okay, so we've got Cl1-. Now, how much total negative charge do we have here? We have 3 Cls, so that's going to be 1, 2, 3. And since we have 3 of them, the total amount of negative charge is going to be 3-. Now, in an ionic compound, the negative charge always has to balance out with a positive charge. So if we have 3- on this side, we've got to have 3+ on this side. So what's the charge on iron now? Well, there is 1 iron ion in this compound, which means that all of the positive charge has to be on this 1 ion, which means that its charge is Fe3+. Okay? So 1 ion of Fe3+ gives us 3+ of charge, which has to be balanced out by the 3- over here, which is distributed over the 3 Cl-. So that's how we figure out the charge on iron. And since this is iron 3+, the name for this compound is going to be iron 3. And then for Cl, when chlorine becomes a negative ion, we call it chloride. The IDE usually gets added to the name of an element when it becomes a negative ion. So chloride is what we call Cl1-. So iron 3 chloride is the name of this compound. We had to work backwards and figure out the charge of iron, and then we can call it iron 3. So if you want to get really good at naming compounds with transition metals and using the Roman numerals and all that, you've just got to get a lot of practice. So I've made another video that's just a whole bunch of practice problems on naming ionic compounds with transition metals. But before you check that out, I want to talk about a couple of important things. The first thing I want to talk about is when we use Roman numerals for naming and when we don't. This confuses a lot of students, okay? So when do we use Roman numerals? Well, we use Roman numerals when we're naming compounds that contain transition metals. So here are 3 compounds that contain transition metals, and as you can see, we use these Roman numerals. And we use the Roman numerals because copper, iron, and vanadium are transition metals, which means that they can make multiple ions with different charges. So we kind of need to pin down the specific ion that we're talking about in each one of these compounds, right? So we put this 1 here to say we're talking about copper 1+, because copper could make other ions. We're talking about iron 3+ here. We're talking about vanadium 4+, because they could be a variety of different ions. Now, on the other hand, we don't use Roman numerals when we're naming compounds that don't contain transition metals, that contain, for example, the metals over here. Take potassium iodide, for example. Potassium, K, is in this column. It's in the 1+ column, which means that in an ionic compound, potassium always makes an ion with a 1+ charge. That's the only choice. It can only be 1+. So we don't need to put a Roman numeral in there to specify that it's 1+, because that's the only choice that it could be. Calcium nitride over here, calcium is in this 2+ column, and it can only make an ion with a 2+ charge in an ionic compound. So again, we don't need a Roman numeral to say that, because there's only one choice, and that's 2+. Now aluminum over here can only make a 3+ ion, so you don't need to use Roman numerals with aluminum either. And I should point out that some of these metals here that are not technically transition metals still can make ions with different charges, so we have to use Roman numerals when we name compounds with tin and lead in them as well. But here's the big point. If you're naming compounds with ions that can make different charges, you always need the Roman numerals. But don't put those Roman numerals in if you're naming compounds with metals that can only make 1 charge. Not only is it a waste of time to put those Roman numerals in, but it's wrong. You just shouldn't put them in there. Now we have to use this method of working backwards in order to name compounds that contain most transition metals. And we also have to use this method to name compounds that contain metals like tin or lead that are able to make more than 1 type of ion. But there are 2 important exceptions that I need to tell you about. And these are silver, Ag, and zinc, Zn. Even though these 2 elements are transition metals, they're only able to make 1 type of ion. So silver, Ag, always makes Ag 1+. It's always 1+ and only 1+. Zinc, Zn, always makes an ion that is Zn 2+. Now, that means that when we name compounds that contain silver or zinc, we don't have to use Roman numerals because we're only talking about 1 type of ion, okay? So a compound like this, AgCl, you don't have to do any math at all. You don't have to use a working backwards approach. You just call it silver chloride. ZnCl here, super easy. We just call that zinc chloride. And since these elements always make ions with just 1 charge, we don't have to use the Roman numerals when we're naming them. So it would be wrong to call this silver 1 chloride or zinc 2 chloride here. There's only 1 possible ion, so we don't use the Roman numerals. We only use the Roman numerals if we're trying to distinguish between multiple types of ions with different charges. So that's an introduction to how we name compounds that have transition metals in them. In the next video, we'll do a whole bunch of practice problems so you can really get the hang of it. This is one of the things that you just get better and better at with more practice. So check out that video. You'll get super good at it really fast.